Alright, so we're back at it. 9.3, jumping in with using quadratic formula to solve equations. Now before break, we were solving equations using factoring. Now we're going to look at some different ways to solve quadratic equations, and in this particular case, using the quadratic formula. So a little bit of review before we get there. So do a little find the square root, give you some time to work on that, and then I'll go over it. So pause here while you work through it. And as we remember, for square roots, we want to break it down. So 36, I'm going to break down, most of you will see that it is 6 and 6, and we can stop there, and that's my pair. And so I pull out a 6, nothing is left on the inside. Now you may have broken down as 9 and 4, and then broke down 9 as 3 and 3, and 4 as 2 and 2, and then you have your 3 and 2, which multiply to 6 there as well. Now 180 is probably not as easy, so I'm going to go 9 and 20. You can go 10 and 18, 3 and 60, any version that you want. 9 becomes 3 and 3. 20 becomes 4 and 5. 4 becomes 2 and 2. I have a pair of 3s, I have a pair of 2s. My 5 is all by itself, so I can pull out a 3 and a 2. And I have that 5 left in there. 3 times 2 is 6, root 5 as my answer there. Alright, next is exactly what we were doing, is I want you to factor and solve. Again, go ahead and pause here, see if you can do these on your own as a nice review, and then I'll come back and work through it. So remember, we want to X box. So on top is A times C, so my A is 1. My C is negative 21, so 1 times negative 21 is a negative 21. My B is 4, so that goes on the bottom there. So then what multiplies to negative 21 and adds to 4? That's going to be 7 and negative 3. Then we get our box. We get x squared, negative 21, 7x, and negative 3x. Then we look for our GCF. GCF here is 7. GCF across the top is x. GCF going up is x, and there's negative 3. So then our factors are x plus 7 and x minus 3. Now that is set equal to 0. So then we can set each factor equal to 0. And then when we solve, you get x equals negative 7 and x equals 3. Now for number 4, before we can solve, what we need to do is we need to add that 4 over, because we need to get it set equal to 0. And we get 3x squared plus 8x plus 4 equals 0. Still going to X box here. My A is 3, my C is 4, so that is 12. And then my B is 8. So what multiplies to 12 and adds to 8 is going to be 6 and 2. Box that, and you get 3x squared there. We get 4 here. Notice and remember that I'm pulling it from my original, not from the 12 that we had up here. And then I get 6x and 2x. So my GCF across the bottom is 2. GCF across the top is x. GCF going vertical now is 3x. And GCF is 2. So then, as we continue to solve this, it gives me x plus 2 times 3x plus 2. And that's equal to 0, so I get x plus 2 equals 0. and 3x plus 2 equals 0. Subtract 2, and x equals negative 2. Subtract 2 here as well, but this time we have a 3x, so we need to divide by that 3, and then x equals negative 2/3. So our two answers are negative 2 and negative 2/3. Alright, so our essential question now that we're jumping into the new stuff is, what is the quadratic formula and how can you use it to solve quadratic equations? So we want to be able to answer this question by the end of this set of notes. Okay, so let's actually start by deriving the quadratic formula. That way you know where it comes from. So to start here, we're going to divide everything by a, which then gives us x squared plus b over a x plus c over a, and that equals 0. And from there, there's actually this process that we haven't quite learned yet, which is called completing the square. In that, there's a mini little formula that allows us to complete the square to make it easier to factor. And so what that does for us is it gives us this extra term that is b over 2a squared and then what we add, we also have to subtract. That way it is really 0 that we added. And from there, that then allows us to factor this first portion, which then becomes x plus b over 2a squared. And then dealing with this portion here, off to the side here, I want to combine those like terms. So I have c over a minus b squared over 4a squared, which now I want to combine. In order to combine, I need like terms, or common denominator. So I have 4a squared here and a, which means I need to multiply this by 4a, which then I need to multiply the top by 4a. So then I get 4ac over 4a squared minus b squared over 4a squared. So plus that 4ac over 4a squared minus b squared over 4a squared, and that is equal to 0. I'm now going to move those terms over, so I'm going to subtract this 4ac over 4a squared and add this b squared over 4a squared. And so that gives us x plus b over 2a squared equals b squared over 4a squared plus minus a 4ac over 4a squared. And then from there, we can combine that. I know we wanted to combine it earlier, or I talked about it, but it's easier just combining on this side. So then we get b squared minus 4ac all over 4a squared. Then we want to take the square root. That cancels that out. And we get x plus b over 2a equals the square root of b squared minus 4ac. And then on bottom, the square root of 4 is 2, and the square root of a squared is just a. And then don't forget, as we talked about when we solved by taking the square root, we're going to have that plus or minus in front. And then we're going to subtract b over 2a. And you get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then we have common denominator, so we're going to go and combine those. And you get negative b plus or minus b squared minus 4ac all over 2a. And that there is your quadratic formula. Okay, and for a little fun, you can go ahead and play the video here.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
And there is the quadratic formula and a nice little song. Alright, so actually using some of this. So first use is the discriminant to determine the number of real solutions. Now the discriminant is, when we go back to our formula, was negative b plus or minus radical b squared minus 4ac all over 2a. Well, our discriminant is what is under our radical. So just that b squared minus 4ac. So we can use that to determine how many real solutions that we're going to get. So if I use that with my first one here, so remember it's a, b, c, so b squared is going to be a negative 4 squared, minus 4, my a is 1, and my c is 3, so negative 4 squared is 16, 4 times 1 is 4, times 3 is 12, and that's subtracted, so 16 minus 12 is positive 4. So when we get a positive number, we're going to have 2 real solutions. Now looking at number 6 here, so same idea. I have my a, b, and c. So this time is negative 2 squared minus 4 times a, which is 1, times c, which is 2. So negative 2 squared is 4. 4 times 1 is 4, times 2 is 8. So 4 minus 8 is a negative 4. And when it is negative, we have 0 real solutions. Alright, so what I want you to do is reflect. When the discriminant is positive, the quadratic equation has 2 real solutions. We saw that. When the discriminant is negative, there are no real solutions. We saw that. How many solutions does a quadratic equation have if its discriminant equals 0? And then I want you to explain. So go ahead and take a minute, jot down your answers, and we will discuss this one when we come back into class. So this is your practice on checking for the discriminant and how many real solutions are there. So go ahead and pause here so that way you can work through this. Alright, so that we can check our work, remember again we are just using the b squared minus 4ac to check our discriminant. So here we get 4 squared minus 4 times 1 times 1. So 4 squared is 16. 4 times 1 is 4, times 1 again is 4. And then 16 minus 4 is 12. And then since that is positive, we get 2 real solutions. And as we look at number 8 here, our b is negative 6 squared minus 4a, which is 2, c, which is 15. Negative 6 squared is 36. 4 times 2 is 8. Times 15 is 120, and we just have one negative. And when we subtract those, that gives us negative 84. And since that is negative, we have 0 real solutions. Alright, so now we're going to solve our equation by using the quadratic formula. And identify our a is 2, our b is 3, and our c is a negative 5. So we get x equals negative b, which is 3, plus or minus radical b squared, which is 3 squared, minus 4a, which is 2, and c, which is negative 5. And then all divided by 2a, which is 2. Then we're going to simplify. And so we get negative 3 plus or minus the square root of 9. And then 4 times 2 is 8, times 5 is 40. Notice I don't deal with the negatives until after I'm done multiplying. And then 2 negatives there will make that a positive. So then we get 9 plus 49. Sorry, 9 plus 40. And that's all over 2 times 2, which is 4. Then simplify again, so we get negative 3 plus or minus the square root of 49 all over 4. And then taking the square root of 49, that brings us to negative 3 plus or minus 7 over 4. Then negative 3 plus 7 is 4 over 4, and negative 3 minus 7 is going to be a negative 10 over 4. Simplifying that down, 4 over 4 is 1, and negative 10 over 4 becomes negative 5 over 2. Alright, so looking at this one, before we can solve, what we need to do is get it set equal to 0. So I'm going to subtract the negative 2x over, and that will then give us a positive x squared. So it's 0 equals x squared minus 2x minus 4. It doesn't matter which side the 0 is on, as long as we keep our a positive. Now we're going to solve by the quadratic formula. And so we get x equals negative b, which is a negative 2. So don't forget that negative in front and the negative that is with the b as well. Then we get plus or minus the square root of b squared, which is negative 2 squared, minus 4a, which is 1. times c, which is a negative 4, and then that is all over 2a, which is 1. Alright, then simplifying from there, we get two negatives there, make a positive 2, then we get plus or minus the square root of negative 2 squared, which is 4, minus 4 times 1 times 4 is 16, and then the two negatives make a positive, and then all over 2. And then from there, we're going to want to combine our like terms inside, so we get 2 plus or minus the square root of 20, all over 2. And then taking the square root of 20, and that breaks down to 4 and 5. 4 breaks down to 2 and 2, so there's my pair of 2's that I can pull out, and then 5 is left on the inside. So that gives us 2 plus or minus 2 root 5, all over 2. And then notice that they all have a 2 in common, so 2 goes into 2 once, 2 goes into 2 once, and 2 goes into 2 once, leaving us with 1 plus or minus the square root of 5. And since 1 and root 5 are not like terms, we cannot combine them, so that then is your final answer. Alright, so this one here is your practice. I want you to go ahead and work through this one. We will go over it once we come back into class. My suggestion on this, even though it is more steps, I would keep my a positive by subtracting 8x and then adding 7 to get it set equal to 0. With the quadratic formula, it's not as big of a deal to keep your a positive, but it's always nice to just stay consistent with that. Alright, so using the discriminant with real world models. And so what we're going to do here is we have a diver who jumps from a platform 10 meters above the surface of the water. The diver's height is given by the equation h equals negative 4.9 t squared plus 3.5 t plus 10, where t is the time in seconds after the diver jumps. For what time t is the diver's height 1 meter? So with this, one of the benefits we can do before we jump in and fully solve is we can check to see if there are actually any real solutions. Now, remember here we need to substitute our height of 1 in for h. So we get 1 equals negative 4.9 t squared plus 3.5 t plus 10. Then from there we're going to subtract that 1 over. Gets it set equal to 0. And we get 0 equals negative 4.9 t squared plus 3.5 t plus 9. Now we can check the discriminant. And remember our discriminant is 3.5 squared, so that's our b minus 4 ac, which is negative 4.9, times c, which is 9. So then using a calculator to do the work for us, so I plug in 3.5 squared minus 4 times the negative 4.9 times 9, which gives us 188.65. And that is the discriminant. Since it is positive, that then tells us that there are two real solutions, so then we can go ahead and move on to the next step of solving. Since we have two real solutions, we're going to substitute our 1 in for h, and then go ahead and get it set equal to 0 in order to solve. And so, as we already did, we get 0 equals negative 4.9 t squared plus 3.5 t plus 9. And then from there, we're going to substitute that into our quadratic formula. So x equals negative, which is negative 3.5 plus or minus the square root of b squared, which is 3.5 squared, minus 4a, which is negative 4.9, times c, which is 9, all over 2a, which is negative 4.9. 6.9. Now, here we're going to simplify, and we're going to be using a calculator. The nice thing at this point is we know already what the discriminant is. So then we get negative 3.5 plus or minus the square root of 188.65, because we already figured that out, all over negative 9.8. And then from there, continuing to use our calculator to simplify our square root of 188.65. That gives us negative 3.5 plus or minus 13.73 all over negative 9.8. And then I'm going to end up writing those as two separate equations because we need the negative 3.5 plus 13.73 over negative 9.8, and then we negative 3.5 minus 13.73 over negative 9.8. And then simplifying both of those, again using a calculator to punch in those values to come up with our end results. And we get 10.23 over negative 9.8, which then is a negative 1.04. And on the other one, negative 3.5 minus 13.73 is going to be a negative 17.23 divided by a negative 9.8. And once we divide that, we get 1.76. Now putting this back into context, so those are real solutions, but we're dealing with the real world. And so remember, it is t equals, and remember t stands for time, which means negative 1.04 is not a valid answer. And then so we get 1.76 seconds as our actual solution to this problem. Alright, so your practice on this one. So you have the height in meters of a model rocket on a particular launch can be modeled by the equation h equals negative 4.9 t squared plus 102 t plus 100, where t is the time in seconds after its engine burns out 100 meters above the ground. When will the rocket reach a height of 600 meters? So then what we need to do is substitute 600 in for h, and just like we did before, get it set equal to 0, and then use your quadratic formula. We will go over this one in class as well. Alright, so looking at this one, just to give you a little bit of work here, we have our height, which is 600, so we're going to substitute that in for h. And then we're going to subtract that 600 over to get it set equal to 0, which gives us negative 4.9 t squared plus 102 t minus 500. Substituting that into the quadratic formula, and then, which I'm going to let you do on your own. If you have any question, I'll answer in class. Gives us t equals negative 7.9 and 12.92. Again, real world context. Negative time does not work, so negative 7.9 is not a solution, so we get 12.92 seconds for our final answer. So elaborate on this. What advantage does using the quadratic formula have over other methods of solving the quadratic equations? Write your answer down. I'll call on several of you to share out what you got when we get back into class. Alright, so our essential question check-in. How can you use the quadratic formula to solve quadratic equations? So I went through several problems. What I want you to do is write down your thoughts here, and again, I'll call on several of you to share out on this. Now, before you move on to your assignment, do not forget your quizzes. which goes along with this lesson. So make sure you complete those questions there as well. Then your assignment for 9.3 is page 389, numbers 1 through 15 odd, 16 through 19. You can do it in the workbook, you can do it digitally. We will work on this in class, in the next class period.